Good morning, boys. Today, let us start with the miscellaneous exercise. You would have already done the first and the second questions, so I am starting with the third question onwards. The third question says that we have to prove that 2 sine inverse 3 by 5 is equal to tan inverse 24 by 7. Now again, like the procedure which we followed earlier, we'll be starting with the left hand side, and now here we will convert it to the right hand side. So let sine inverse 3 by 5 equal to x. This gives us sine x equal to 3 by 5. Now we take the Pythagoras triangle, and then here in that, if sin x is 3 by 5, so you write 3 here and 5 here, and so this becomes 4. Now from here, this is also equal to, if you find the value of tan x, you get tan x equal to 3 by 4, and which gives us tan inverse x 3 by 4 equal to x. From here, tan inverse 3 by 4 equal to x. X is equal to sine inverse 3 by 5, which is also equal to tan inverse 3 by 4, and so this is equal to tan inverse 3 by 4. But now in the left hand side, we have to find the value of 2 sine inverse 3 by 5. This becomes 2 tan inverse 3 by 4. Now we have a formula for this in terms of tan, because the right hand side we have a tan inverse function, so we will use that formula of 2 tan inverse which deals with tan. So you will be writing it as tan inverse 2 into 3 by 4 upon 1 minus 1 minus 3 square over 4 square, which becomes tan inverse 2 into 3 upon 4 upon this becomes 16 minus 9 over 16, and this gives us tan inverse 6 into 4 over 7, which is tan inverse 24 by 7, which is the right hand side. Now same way in question number 4. Now here the question says sine inverse 8 by 17 plus sine inverse 3 by 5 equal to sine inverse 8 by 17 plus sine inverse 3 by 5 equal to tan inverse 77 upon 36. Now in this case, we don't have any formula for the sum of two sine inverse functions, but we do have a formula for sum of two tan inverse. So we will convert both of these sine inverse functions on the left hand side in terms of tan inverse. So how do we do? This becomes what? This, if you just use the Pythagorean triangle, this is 8 upon 17, and so the third side becomes square root of 17 square minus 8 square, which comes out to be 15. And here if you just see, this is 3 upon 5, and 25 minus 9 square minus 9, the square root becomes 4. So the left hand side becomes, now we have to write it as in terms of tan inverse. Sine inverse 8 upon 17 is equal to tan inverse 8 upon 15. If you can't do it directly like this, you can do it in the same manner as we did the previous question, that we will assume the sine inverse to be x and then equate it to x in terms of tan inverse and hence convert. Now here this gets converted to tan inverse 8 upon 15 and this gets converted to tan inverse 3 upon 4. Now again, since the product of these two is less than 1, we will apply the result of tan inverse x plus tan inverse y. It comes out to be tan inverse 8 upon 15 plus 3 by 4 over 1 minus 8 over 15 into 3 by 4, which on solving gives us tan inverse 32 plus 15 over 60, and this is 60 minus 24 over 60. This gets cancelled and this gets solved to tan inverse. This becomes 77 upon this becomes 36, which is the right hand side. In a similar fashion, we will be doing the rest of the questions also, like question number 5th can be done like the same in the same manner, which deals with sum of two cos inverse functions. So we will convert, if in case of question number 1 we have cos inverse 4 by 5 plus cos inverse 12 by 13 to be proved to cos inverse 33 by 65. So what we will do is we will convert these both cos inverse functions to tan inverse and prove it to the right hand side. We can do it in this manner. 4 by 5 means base upon hypotenuse, and this is 12 by 13 means base upon hypotenuse, and this gets solved to. Now what do we get here? The third side would be 3 and here the third side would be 5. So the left hand side becomes tan inverse 3 by 4 plus tan inverse 5 by 12, and which becomes tan inverse 3 by 4 plus 5 by 12 upon 1 minus 3 by 4 into 5 by 12, which gives us tan inverse 36 plus 20 upon 48 whole upon 48 minus 15 over 48. This gets cancelled and you get it as tan inverse 56 over, this is 3 and then you are left with 33. Now if you just observe, the right hand side is also in cos inverse. So we need to further solve it and convert it to cos inverse. So let's start with tan inverse 56 by 33. So using the Pythagorean triangle, this becomes the opposite side is 56, this side is 33, and then when you solve it, this will be under root of 56 whole square minus 33 whole square, which gets solved to 65, and so this becomes cos inverse, now 33 upon 65, which is the right hand side. In the same manner, the sixth question involves one cos function and one sine function. So what do we do? Cos inverse 12 upon 13 plus sine inverse 3 upon 5 equal to sine inverse 56 over 65. So now here again all need to be converted to tan inverse and then proceed in the same manner. So left hand side is this is what? Here you have to be careful where we are using a cos inverse and where we are using a sin inverse, and accordingly we function. So here there is a cos inverse function, so base upon hypotenuse, and here there is a sin inverse function, so opposite side upon hypotenuse. So the third side becomes 5 here, and here the third side becomes 4 here. This gets converted to tan inverse 5 by 12 plus tan inverse 3 by 4, which on applying the formula for the sum of two tan inverse functions gives us tan inverse, this gives us tan inverse 56 over 33. Now we have to convert this in the on the same lines as this one. So we have tan inverse 56 means the opposite side and the base is 33, and just as how we solved here, the third side becomes square of this minus square of this, which is an under root, that is 65. This gives you, now here on the right hand side we are expected to write in terms of sin inverse. So here this is equal to sin inverse. Sin inverse will involve opposite side and hypotenuse. So you have 55, this is 56. So 56 over 65, which is the right hand side. So in this manner you can try all questions of this kind.